What are chemical bonds? There are intramolecular bonds, which are bonds within each molecule, and there are intermolecular bonds, which are bonds between molecules. Let's look at intramolecular bonds first. These are bonds within the molecule. There are three main types of bonds. Firstly, we have covalent bonds, which are bonds found in water or hydrogen. Next, we have ionic bonds, which are bonds found in sodium chloride, also known as table salt, and calcium hydroxide, also known as lime water. Finally, we have metallic bonds, which are bonds in metals such as zinc or iron. Let's find out more about covalent bonds. Covalent bonds are bonds between nonmetallic atoms. An example of this is bonds in the water molecule. The aim in covalent bonding is to create stability between the atoms. This is done by the sharing of outer shell electrons between different atoms so that the outer shell has 8 electrons. This is known as the octet rule. This sharing of electrons creates a covalent bond. Each of these pairs of electrons are known as shared pairs. As their bonds are super stable, they are super strong. There are two types of covalent bonds, polar and nonpolar covalent bonds. This is driven by the electronegativity between the atoms bounded by the covalent bond. Electronegativity is the power of an atom to attract electrons to itself. Each atom has its own electronegativity. For example, chlorine has an electronegativity of 3.6, hydrogen 2.2, nitrogen 3.04, and fluorine 3.98. Polar covalent bonds are formed when the two atoms bonded together have an electronegativity difference of 0.4 or more. In polar covalent bonds, a dipole moment is formed between the partially positively charged atom and partially negatively charged atom. The greater the electronegativity difference between the two atoms, the stronger the dipole moment. The most electronegative element is fluorine. On the periodic table, the electronegativity increases as the element is closer to fluorine. Nonpolar covalent bonds, on the other hand, are formed when the covalent bond is between two atoms with an electronegativity difference of less than 0.4. Covalent bonds can come in multiple bonds, single, double, triple, etc. This correlates to the number of shared electron pairs. In general, the greater the number of bonds between the atoms, the stronger the bond. The next type of intramolecular bonds are ionic bonds. These are normally formed between a metal and a nonmetal. In ionic bonding, one or more electrons are donated from one atom to another. This creates a positively charged ion, or a cation, and a negatively charged ion, or an anion. These oppositely charged ions attract each other through electrostatic forces, forming an ionic bond. The last type of intramolecular bond are metallic bonds. This is formed by an electrostatic attraction between positively charged metal ions and delocalized electrons. These electrons are from the outer shell, also known as valence electrons, and move freely around. This forms a lattice of positive metal ions in a sea of electrons. So, to sum up, intramolecular bonds are bonds within the molecule, and there are three main types. Firstly, covalent bonds, which are bonds between nonmetals. Secondly, ionic bonds, which are bonds between metals and nonmetals. Finally, metallic bonds, which are bonds in metals. Now let's look at intermolecular forces, which are found between molecules. There are three main types. Firstly, there are dipole-dipole interactions, like between hydrogen chloride molecules. Next, we have hydrogen bonds. like between water molecules, and finally van der Waals forces, or London dispersion forces, like between chlorine molecules. Firstly, we have dipole-dipole interactions. These normally happen between polar covalent molecules. These are forces between the partially positively charged part of a molecule and the partially negatively charged part of the neighboring molecule. The next type of intermolecular forces are hydrogen bonds. This is a special kind of dipole-dipole interaction. Examples include hydrogen fluoride and water. This is limited to molecules with hydrogen covalently bonded to oxygen, nitrogen, or fluorine, which then interacts with another strongly electronegative atom. The final type of intermolecular forces are van der Waals forces, also known as London dispersion forces. These are forces which are created by induced electrical interactions between two or more atoms or molecules that are close to each other. This type of force is found between all types of molecules. So, in summary, there are three types of intermolecular forces. Firstly, dipole-dipole interactions, which are found between polar covalently bonded molecules. Next, hydrogen bonds, which are found in polar covalently bonded molecules with an HF, HN, or HO bond and another electronegative atom. And finally, van der Waals, or London dispersion forces, which are found between any molecules.
That's all for today. If you enjoyed our lesson today, please subscribe using the link below.